So today we're going to be talking about assemblies in Onshape. I'm going to go ahead and open up an example that I created to kind of be able to talk about this with you. So here's my example assembly. And what we need to know about an assembly in Onshape is that it does a couple of important things. So right now, if you look at these pieces right here, these are individual part studios. And I can have a part studio that has multiple parts in it, like this one, or a part studio that just has a single part in it. And what I can do with an assembly is I can bring those parts together in certain specific ways to create more complex things. And so the first thing that I'd like you to write down about assemblies is that an assembly defines the relationship between two or more parts. So I'll say that again. An assembly allows you to define the relationship between two or more parts. And so in this example that I've got up on the screen here, I've got multiple parts. Some of them came from one part studio, some of them came from another part studio, and they all come together into this assembly. So I've already put everything together in this one. What I'm going to do is kind of talk through what assemblies are using this example, and then I'm going to show you techniques for actually creating your own assemblies after that point. So first things first, what kinds of things can I do in an assembly? Well, I can join pieces together. I already said that an assembly allows you to define the relationship between two or more parts. The other thing an assembly does is it allows you to constrain or allow movement between different parts. So that's the second thing I'd like you to write down. An assembly allows you to constrain or allow movement between two parts. I should really say two or more parts, because we can have multiple of those. So if you look at my example assembly, I've got a few things going on here. I have this mounting bracket right here, this sort of L-shaped one. I've got the base plate, which is the thing that we modeled the other day to practice our holes assembly. I've got this top piece up here, and I've got this bolt right here. So if we look at this, first things first, I can't move this around at all. I can click and try to drag around on there, but I can't move around anything on there. This base plate is stuck down to the mounting bracket. I can, however, grab this piece right here, this little spinning indicator, and I can just spin it around. The other thing I can do is I can grab this bolt and I can move this up and down. And what else do you notice about this bolt as I'm moving it up and down? It's not as easy to see as I would like on here. What else do you notice? Yeah, this bolt also rotates as I move it up and down. So you can kind of think of this as being like the way that a bolt spins as it's moving, being like screwed into a threaded hole, right? So how do we put all this stuff together? Let's take a look at that. I've got a blank assembly right here, and the first thing I want to show you is that an assembly view looks very different in some ways than a part studio, but has some similarities as well. So the first thing I want to do is I'm going to insert some parts. Those parts can be from a single part studio, or they can be from multiple part studios. I'm going to go ahead and actually say I want this base plate. I want 4 of these bolts, 1, 2, 3, 4, and I want 1 of these spinning indicators. And then I'm going to open up this part studio, and I want 1 of these mounting brackets. I'll click the green check, and then if I zoom back, everything is right there. It's all kind of jumbled up. It just sort of placed it wherever it felt like, so to speak. And one immediate difference you can see with the assembly is that when I first pull these parts in, I can just grab stuff and move it around. Like these two things came in looking like they were attached together, but they're not. They just happen to be modeled in the same place in the original part studio. Okay? So I can grab any of these things and I can just put them wherever I want. So the first thing I want to be really clear about is when we're making assemblies, what we're not doing is just grabbing these things and trying to visually kind of drag them up to where we think they should go. That might be tempting to do at first, but that's not what we're trying to do here. So in other words, I could grab this base plate and I could go to my front and right views, and I could even look around from like the bottom, and I could say, you know what? Looks good to me. It looks like those mounting holes are lined up, so this thing is good in my assembly. But what's the first thing that I said an assembly allows us to do? It's the first thing that you wrote down. Take a look at your notes. Who else has one? You already contributed, which I appreciate. Who else has one? Yeah. Yeah, so an assembly allows you to define the relationship between parts. Right now I have not defined that relationship at all. I just kind of stuck the two things close to each other in space, but I didn't define that relationship because I can just as easily grab that and drag that around, and it still lets me do that. Okay? So when we're assembling, what we're going to do is we're going to define how those parts connect to each other and relate to each other. Sometimes they'll have certain kinds of movement, other times we'll take away movement. Before I get into that, the very first thing that I usually want to do when I'm assembling something is I want to fix one of the parts. And when I say fix here, I don't mean like repair, I mean fix like hold it in space, right? It needs to be fixed. And typically you like to do that with whatever the sort of main part is that you're going to be assembling stuff onto. So for me, I think this bracket here is kind of the main part. I can right-click on it in the workspace, and I can choose Fix. Or I can come over here to my Instances list, and I can choose Fix. One quick thing, you notice that all of these parts are named so that the name reflects what they are. So if I go back to the Part Studio, this overall Part Studio is called Mounting Bracket, but the individual part is also named Mounting Bracket. If I come to the base plate one, same thing. Base plate, bolt, spinning indicator. So if you haven't already gotten into this habit, when you make a part, go in and rename it so it says what it is. So the name actually indicates what it is. Because once you start putting those things into an assembly, it's going to make your life way easier. If you don't do that, all of these will come in as things like Part 1, Part 2, Part 3, Part 1, and it's going to be useless in terms of trying to figure out what's what. All right? So I want that mounting bracket to be fixed, to be the main part that I assemble everything else onto. So I'm going to right-click on it and choose Fix. So now if I try to grab it and drag it around, nothing happens. It just stays put. I can still move around this mounting plate, but the bracket itself stays put. So I want to stick this onto this. And in order to do that, what we're going to use are what Onshape calls mates. So I'm going to ask you to write down a couple of these things and a little bit of information about them. We're not going to go through every single one, but I want to show you kind of a few of the most common ones and get a chance to talk about this. So this first one is called a fastened mate. And like the little tooltip says when it pops up, this removes all degrees of freedom between two entities. So at the very least, write down that fastened mate is the name of one of those. And you can write down the definition, or you can just write down, basically, this sticks two things together, and they don't move at all. Okay? A fasten mate just allows you to stick two things together. The way it says is that it removes all the degrees of freedom. Another way to say it is, they can't move relative to each other. Those two parts are just stuck together. Okay? So that's a fastened mate. The next type of mate over there is probably like the second most common, and it is a revolute mate. And what a revolute mate allows us to do is to have one part that spins around another part, or inside another part. So when we're doing this in Onshape, the first selection you make is the part that's going to spin, and the second one that you select is the one that's going to stay stationary. It's going to stay put. So it's kind of like what's rotating and what. So revolute mate is kind of the second most common one. Then we get some more that we may or may not use. A slider mate is pretty common. It just allows two things to slide in relationship to each other. So imagine a drawer. You're going to grab the drawer and you're going to pull it open. Those slides that are along the side is a great example of a slider mate, where one thing is sliding past the other. So in technical terms, what we say is that that thing is translating. It's moving. It's got linear motion just in one direction. So if we look at that technically, it says it allows translation along the z-axis. So two things are sliding relative to each other. Next, we've got a planar mate. Planar mates are a little weird They're not that common. We don't use them that often. But here's a good reference point. How many of you ever played air hockey? You've at least seen somebody play air hockey. Okay, like in an arcade, like you've gone to Pinball Pete's or something and somebody's playing air hockey. All right, so a planar mate is kind of like an air hockey table. Here's how it works. Imagine the puck in your air hockey game. It can slide side to side, front to back. It can kind of go anywhere along one flat surface, right? While it's moving, it can also spin, right? Especially if you hit a little shot where it hits it from the side, and that puck can also spin, right? A planar mate works exactly like that. It can go side to side, front to back, so it can translate along the X and Y axes, and it can also rotate around the Z axis, which is the one that's pointing straight up in Onshape, okay? So it can do just like an air hockey puck, basically, okay? And then the last really common one is a cylindrical mate. And so this is like what I showed for that bolt. We can translate, so we can move up and down in the Z-axis. And we can also rotate around the Z-axis. So just like I showed that screw or that bolt being able to move up and down but also spin as we did that, that was a cylindrical mate. And again, you don't have to write down all the notes for every single one of these things. I just want you to kind of be aware that these things exist. And I'll show you specifically how we put them into effect. We've got some more, some less common ones over here, like pin slot and ball and parallel and tangent mates. I don't need to worry about those things right now. We'll get to those things eventually. But for right now, we've got some basics that we can use. All right, so here are all my parts. I've fixed this one in place. I want to stick this mounting plate to the, this base plate to the mounting bracket. Which of those mates do you think would make sense here? I just want to stick one thing to the other. Yeah, what do you think? Yeah, I'm just going to grab a fasten mate. It's probably the most common one that you'll use. And in order for me to say how those two parts are stuck together, I have to select what are called mate connectors. So when I hover over a part, once I've selected a mate, these little symbols are going to pop up. This little one that kind of looks like a circle with a wedge taken out of it. This little kind of pie shape right here, right? You're going to see mate connectors that pop up on flat surfaces. It does have to be a flat surface. You can't get a mate connector on a curved surface like the outside face of the cylinder. You can do the top face where it's flat, but not the circular face, okay? So right away, if I move over towards the middle of the part, I see a mate connector on that flat face right there in the middle. If I move over to the edge, though, this is where it gets a little trickier. I see a mate connector on this sort of back left corner, but if I move my mouse a little bit, I also see one that's turned by 90 degrees, right? So you got to be kind of careful which axis you're choosing the mate connector on. I'm going to zoom back some, though, because I'm just going to choose this one right here. So I want the top of my bracket stuck to the bottom of this base plate. But there's one thing that's weird. There's a big hole in that base plate where I think I want that. That's okay. I can still go ahead and choose that one. And what you're going to notice is that that part has now moved over and it's stuck to the first one. I'm going to click the green check for now, but then I want to show you something. Because I had this mounting bracket fixed in space so it can't move, now that I've fastened this to it, neither one of those parts can move, right? They're just fastened together. The only problem is, if we look at this from the bottom, you're going to notice that those mounting holes do not quite line up, right? So that's one of the most powerful things we can do with a fasten mate, is we can adjust that. I'm going to double click that fasten mate and open it back up, and I'm going to click offset. When I do that, what I can start to see is that I can offset my two parts compared to one another across a few different directions. I could go in the X direction, which is the red axis right there. I could go in the Y direction, which is the green one. And I could go in the Z direction, but it's hard to see because it would just look like a point since it's going straight out from where we're at. I want to move this over a little bit in the X direction, so there's two ways you can do this. You can either go in and type in a specific number, and that didn't work because that's way too far. Or what I can do is, if you're not quite sure, I'll leave that back at 0. If you're not quite sure, you can click into there, and then you can use your up and down arrow keys on your keyboard to kind of gradually move them 1/10 of an inch at a time. Right? So if I, let me me zoom back in here a little bit. So if I click back into there, I can just use my up and down arrow keys to kind of nudge it over 1/10 of an inch at a time. Okay, so if you need to kind of guess and check, that's a nice way to do it. A better way to do it would be to go back into the sketch, find out how far from the edge each of those holes are, and then use that to adjust your offset, right? But for this, I was able to just kind of guess and check my way over to negative 0.2 inches. So those two parts are not only fastened together now, they're also lined up exactly where I want them, because what I'm going to want to do is put a bolt through there into that mounting bracket, so it actually holds it in place, right? So even though these things are stuck together in CAD, you know if you actually put them together in the real world, they could just slide around, right? Unless we put some glue or something in there, which we're not going to do in this case. So let's pretend that we're going to do the next part. Let's actually do the next part. Next part I'm going to do is this little spinning indicator. So what I want to do is, by the time I'm done, this thing should be able to just spin around in that hole. So what do you think? Take a look at your notes. Which type of fastener, or which type of mate, rather, do I want to use? Yes, Evan? Yeah, I'm going to grab that Revolute mate. That's okay. That's all right. So if you remember, if you look at this again, what it says for the Revolute mate is the first thing is going to be the rotational point. That's going to be the thing that spins. And the second one is going to be the stationary point. So it's going to stay put. So I want this thing to spin. So I'm going to rotate around. This is also where having a mouse makes it so much easier. I'm going to click on this mate connector at the bottom. And then I want to click on the mate connector at the bottom of this hole, but it's a little tricky. So one thing you'll probably find yourself doing a lot when you do assemblies is that you may want to turn off the visibility on those parts. So just like you can do that in a part studio, just click the eyeball, turn off the visibility for a minute to make it easier to find what you need to connect to, because I want the mate connector that is at the bottom of that hole right there. Now, one quick thing. If I click the green check on this box right here, Onshape's going to think that I want to do another assembly or another mate of that exact type. So it's going to be like, okay, you just finished that first Revolute mate. Let's get you set up for a second Revolute mate. And sometimes you might want to do that. In this case, this is the only one I'm going to use. So I'm just going to click the green check right here. So we've got these two parts. This spins around. This is mated to that part we turned the visibility off, so we can turn that back on. And we're most of the way there already. We've got the base plate mounted to the bracket. We've got this part that spins around. Cool. Last part of the bolts. I'm just going to do one of these to demonstrate. And this is the last type of mate connector we need for today, for this one. I'm going to choose a cylindrical mate, like I mentioned earlier. And I'm going to do a very similar thing. I'm going to grab this one right here. And I'm going to grab this mate connector at the bottom of this hole. And that should be set up and good to go. I should be able to just click the green check. And now if I grab this, I can not only pull it out, but I can also spin it around. However, there's one last thing I want to show you. I can move this thing up and down and spin it around, but I can also drag it through that whole thing. It can clip right through that entire thing, which we know in real life is not going to happen because there's a counter bore there where this thing should stop. That would stop it from going all the way through, right? So one last thing really quickly is that I can set a limit on a mate. So I can say I want to limit how far up it can go and how far down it can go. Those are going to be the Z distance limits right here. So I could say, let's say 0 and let's say -1. Let's say, oh, sorry, that was the maximum. Let's say the minimum distance is 0 and the maximum distance it can go is 1. So let's see if I guessed correctly. Wait, I went the wrong way. So let me go back and fix that. Let's say the maximum should be 1. I'm sorry, let's say the minimum should be -1 and the maximum should be 0. Let's see if I got it right this time. All right, so the bolt can come out, and that's as far down as it can go. That looks pretty good, right? I can pull the bolt out, I can push the bolt down, and that's as far as it can go. So that's a way to add some extra realism to your assemblies, to show how parts can actually move compared to each other. I could go through and put all those other 3 bolts in. It's going to be the exact same process, so I'm not going to do that. So we're going to stop right there with this demonstration. I'm going to stop my recording, and we can chat.